So the last problem I want to do is 88A. I'm not even going to do part B, and you can do 87 as maybe while I'm doing this. But 88A wants me to graph a square root and it doesn't give me a table. Same deal again. I'm going to make a table. I'm going to sketch a graph. After I get the graph, I'm going to write the domain, and I'm going to write the range. I know because I'm doing a square root in our class, for all the square root graphs, the domain is going to be square bracket, comma, round bracket. And similarly, I'm going to find the range, and for our graph, our class, all square roots are going to have a range of square bracket, comma, round bracket. For my table, I don't worry about this +1. For my table, since I'm not given a starting table, I'm just going to take the radicand of x minus 2, ignoring the +1. I'm going to set it equal to 0, and I'm going to solve for x. That's going to have me put 2 in the middle of my x column. So in my table, I'm going to put 2 in the middle of my x column. I'm going to go bigger and smaller. For my y's, I'm just going to take each of the numbers in the x column and plug them in for the y, for the x in the under the radical. When I'm doing square roots, I'm going to get some errors that aren't going to graph. And that's why the domain isn't negative to positive infinity. If I was doing this by hand, the very first point would ask me to do the square root of a negative number, and that's going to give me an error. But I'm going to do this just on my calculator. I don't know how foreseeable it's going to be. So first point, I'm going to do square root of 0 minus 2, arrow out, +1, gives me an error, so that's not going to graph. I'm just going to write error in my y column. And then second point, square root of 1 minus 2 +1. I'm also going to get an error because this piece right here comes out to -1, and the square roots of negatives are imaginary numbers. Next one's going to work. Square root of 2 minus 2 +1 gives me 1. That's going to be the first point on my graph, the point that I need for the domain and the range. And now I can finally go back and just square root of 3 minus 2 +1, which is 2, and square root of 4 minus 2 +1 SD it is 2.41. So now I'm going to sketch a graph. I'll sketch it up here because I'm kind of shy in room. My x-axis needs to go out to 4. So this is my horizontal, this is my x-axis. And my y-axis needs to go up to like 3. And the y-axis I could call f of x. I'm going to label that first point that's not an error because that's the point I need for my domain and my range. So first point that's going to be important to label is the point 2, 1. The other points I could just dot. Then the point 3, 2 and 4, 2.4, just kind of guesstimating. Square root graphs that we do all kind of have the same look. Probably don't have enough bend in this, but it's good enough. I usually put a little arrow at the end because the graph's going to go on forever. So I made my table, I sketched my graph. The domain of all my square roots are square bracket, comma, round bracket. The number that goes next to the square bracket is the x from the start of the graph, which is 2. And then the graph always goes to the right forever, and the end of my domain is always positive infinity for all the square root graphs that we're going to do. Similarly, for the range is going to start at the y-coordinate of this starting point, which is the bottom of the graph, which is 1. And this graph will, if I extend it up and to the right forever, it eventually will work its way to the top of the y-axis. The end of the range is going to be 1. That's the end of what I'm going to graph, because I think it just gets repetitive. You're going to be asked to graph 91. I don't know how well this shows up, but in 91, both of the graphs, the square root graph and the cube root graph, have a more complicated radicand. And for my table, if you're graphing problem 91 for homework, you're going to take the radicand and set it equal to 0, ignoring this plus 1. This plus 1 will come up for the range, but it doesn't impact my table. And I'll do the algebra to isolate the x, meaning I'm going to add 6 and divide by 2. And I get x equal to 3. So if I was graphing 91a, I'd put 3 in the middle of my x column. I'd go smaller a couple and bigger a couple. Similarly, for part B, it doesn't matter that it's a cube root, because the radicand's the same. The algebra to get my table started is going to be the same. Take the radicand, ignoring anything outside the radical, set it equal to 0, solve for x, and 91b. It's going to be the same algebra to get my table started, so it's going to be the same table. So this has been, it's not particularly hard to get the tables the way I'm doing the tables, but it is possible if you own this calculator, or if you own this calculator, to get the calculator to give you the entire table without having to do the individual computations. And maybe I'll record a video to show you how to do that. And I'll just say calculator table video. And if you have my calculator, you can learn how to do the y part of the tables way quicker, and you can do that on the test. All right, I'm going to pause the video now, or stop it.